Hello, hello, friends. We have a few puzzles today by Elytron. This first one is Product Link Somedoku 1 by Elytron. This is Somedoku, which is fill each cell with a digit from 1 to 4. Each row n and each column n must contain exactly n different digits, with repetition allowed as necessary. Ooh, okay. So I'm not necessarily... Okay, I am using the digits 1 through 4, but not once each in every row and column. Each row n and each column n must contain exactly n different digits. So because this is row 1, it'll have 1 different digit. Row 2 will have 2 different digits. Row 3 will have 3 different digits, etc., etc. We also have number link, or Arukani. Oh, look at me using an Americanized pronunciation for a word I don't know. Connect same shapes with continuous orthogonal lines passing through the center of each cell. The lines may not cross or split. Oh, I didn't know that's what that was called. I like games like that. So you would like have to connect the... I should stop doing this. That's part of the puzzle. But you would connect it like that. So I also have to connect same shapes with continuous orthogonal lines passing through the center of each cell. The lines may not cross or split. Okay. If it's number link. Okay, we also have product bands. The product of the digits on 2 of the same shapes must equal the sum of the digits on the line connecting them. Ooh, I was wondering how the numbers would come into play there. The product of the digits on 2 of the same shapes must equal the sum of the digits on the line connecting them. Okay, so this square times square is going to be the same as the sum of the digits connecting the squares. Interesting. Ooh, this will be fun. We don't have any given digits. Fill each cell with a digit from 1 to 4. Each row n and each column n must contain exactly n different digits, with repetition allowed as necessary. Okay, I think I want to start by connecting these. I think that's going to be a good starting spot. Nice. I have done, I would think, thousands of these puzzles. I used to have an app on my phone where I was in like number 3000 before I stopped playing. I did not do a very good job of explaining the product bands before. My apologies. I enjoy doing these puzzles, this kind of puzzle, and so I just went ahead and did it, and I didn't even explain it. So the way I think about this is I need to fill up every cell in the grid needs to either have a shape or part of a line on it, right? So the way I think about it is I see these 3 open cells here and I need to use them somehow. I don't want to bring the red down here because it has nowhere to go. I can't cross through another shape. And I also don't want to bring green down here because I have nowhere to go. I can't cross through another shape. You can't move diagonally. So I know that this has to be blue, and I'm going to fill these cells by connecting the blue here. I also know I need to use green somehow. It needs to connect to each other. I can't go down here now because I already have the blue lines. So I need to go up, and it's just going to connect right here. I don't want to keep going because that'll block off the red. So a nice little, sweet little short line right here, and then red just fills up the rest of the grid. Okay, so that's nice. Now we have these digits multiplied together equal the sum of these digits. These digits multiplied together equal this. Okay, what are my options here? I could have like a 1 and a 4 and a 4. Or like a 1 and a 3 and a 3, a 1 and a 2 and a 2. I could have 2 and 4. I could have 1, 1, 1. Oh my gosh. Was I right about... I don't know who I'm asking. I'm by myself right now. This is row 1, so it only has 1 different digit. This is row 2, so it has 2 different digits. This is row 4, so it'll have 4 different digits. And this is column 4, so it'll have 4 different digits. I believe. So if this is going to be 4 different digits, and I need the sum of this to be this times this, what are my options here? This could be anywhere from 1, 2, 3, which would sum to be 6, to a 2, 3, 4, which would sum to be 9. So this needs to be somewhere between 6 and 9. Well, also, if this is 1, 2, 3, which sums to 6, this is stuck being a 4. So I need to be careful with that. Ooh. So what other options work here? If this can't be 1, 2, 3, then what about 1, 2, 4? And then this would be a 3. This would be 7. I don't want that to happen. That would be difficult. What about 1, 3, 4? Then this would be a 2. And that's an option because this sums to 8. So I could have 2 and then 4 here. That's an option. So this would either be a 2 or what if this was 2, 3, 4? That's 9. I could have 3 and 3, but I can't use another 3. This would have to be a 1. Okay, so let's keep this as 1, 3, 4. I think that's the only way that's going to work. My voice is cracking a lot today. What's going on? Let's make this a 2 then. Go ahead and lock that in. This needs to have 4 different digits. So if this is a 4, then this can't be a 4. Okay. This is a 1, 3. This is going to be a 1, 3, 2. All right. What do I want to look at next? This can only be one different digit because it's column 1. So this is going to have to be 2, 2, 2. Meaning this row 1 will have to be 2, 2, 2. Meaning this won't be a 2. This needs to have 2 different digits. 2 and then this. So these need to either be 2 or whatever this is. This needs to have 3 different digits. I can only use one more out of 1 and 3. This is good. These are different 1, 3s. This needs to have 2 different digits, so it's going to be 2 and then whatever this is. So if this digit is not a 2, this is interesting. If this digit is not a 2, then these need to be the same. Could these be the same? Yes. They could. And then this would just be different. If this is not a 2, let's actually just look at this. That'll just tell me something. 2, 4, 6, 8, 10, 12. The only way to get that is if this is a 3 and this is a 4 with my 1, 3 options here. Nice. Nice. That works out. Well, this could still be a 4. I need to be careful with that. But this is 4 different digits, so this is a 3 and this is a 1. I don't want to get too ahead of myself. This can only be 2 different digits, so these are either 2s or 3s. This column can only be 2 different digits. It needs to be 2 and 4. This can't be a 3. It's going to have to be a 2. This can't be a 3. It's going to have to be a 4. Meaning if I have 4 different digits here, this is a 3. This needs to be 3 different digits. This is either a 2 or a 4. Nope, that's not true. I need 3 different digits. I can't use 2 or 4 again, actually. I need a 3rd digit. This is going to be a 1 or a 3. Okay. This is 2 different digits, so 2 or 3 is fine. This is 2 different digits. This is 3 different digits. I've used 2 and 3, meaning I will have to use either a 1 or 4 in here. I can't use a 4 anymore, so this will have to be a 1. 2 times 1 is 2, so this has to be a 2. Nice! Oh, that is an interesting way of thinking about these. Oh my golly. So many times I wanted to, oh, I've already used a 2, so let's take out a 2. Can't do that. Can't do that. Nice. Okay, this is puzzle number 2. Product like Somedoku 2. I'm assuming the rules are the same. Fill each cell with a digit from 1 to 5. Each row n and each column n must contain exactly n different digits. Sounds good to me. Let's start with connecting these. I don't know if I have to use every single cell. It seems like I might. This is also going to be green, and then we're going to have orange up here. I like how the shades go with the shapes. They look nice. I have, again, lines that I need to fill here. I know they have to be red because if I bring yellow up here, that's not going to work. I can't get back around. There's too many other shapes in the way. So let's just go ahead and fill these out with red. Sometimes you run into the issue where if you just go like this, that's actually not enough. And maybe, nope, that's a bad example. That's not going to happen here. Maybe that'll come up in a second. Red like this. Okay, here. If I were to just connect green like this, that works. But sometimes you run into the situation where you actually need to zigzag a bit in order to fill up the extra cells. So I normally just undo what I did already and fix that at the end. But for right now, looks like green would be fine here. There's also interesting situations like this where yellow could go like this or like this. So you can think about it. If I were to make the yellow line go this way, right, and then up, what do I put in this cell? There's nothing that can go there. So I need to use that one for yellow. Next, how do I use this cell? It's going to have to be blue because that's the only thing connecting those. Then I have the little green plus signs down here. I can connect this way, and the orange one's connected this way. Nice. Better explanation, I hope, than just not saying anything. Okay, so we have those connected. This needs to have 5 different digits. This needs to have 5 different digits. This is all the same digit. Do I want to start here? If this is ones at the lowest, 1, 2, 3, 4, this would be a 1 and a 4. What if this is 2s? 2, 4, 6, 8. This would be a 2 and a 4. Okay. Whatever this is going to be 4x. This will also be x. So this has to be a 4, no matter what. No matter what, that's a 4. Because if this is all the same digit, yeah, that makes sense. That makes sense. Whatever this is 4. Okay. Are there other things, other places where that happens? This is going to all be the same digit. This is all going to be the same digit. It's not a 4. This is not a 4 because this needs to be different than this. I feel like shading even might help. You can do Somedoku on these cells. Like a 4 needs to go somewhere here, but it can't go here, and it also can't go here because this digit needs to be the same as all of this. So 4 goes somewhere here. That's like something to think about later. Okay, what shapes do we have here? This equals this. If this is 1, this could be 1, 1, 1. If this is 2, I think no matter what, this is a 1. 2 equals 2 times 1. Because these are the same. Yeah, I know these are the same. And this times this has to equal this. So this has to be a 1. Okay, cool. That means that this is either a 1 or a 4. Because this row can only have 2 different digits, I've already used 1 or 4. So this has to be 1 or 4, meaning all of these are 1 or 4. And I know that this cannot be a 4, so these all have to be 1s. Interesting. 1 plus 1 plus 1 plus 1 is 4, which is 1 times 4. 1 equals 1 times 1. 1 plus this is going to equal 1 times this. These are different digits. What else do I want to do? These are either 1s or 4s. These are either 1s or something else. This can't be a 1. These could be. These are either 1 or this. What else do I want to look at? I'm not sure. I don't know. This was good. I liked this, and I liked this. How does this work? This times this. Something times 1. This needs to be 1 bigger than this. Like if this is 1, 2, this will be 3 times 1. If this is 1, 3, this will be 4 times 1. If this is 1, 4, this will be 5 times 1. So this is either a 2, 3, 4, and this is either 3, 4, 5. Okay, what could I do with that? These are either 1 or this. I do need a 4 to go somewhere down here, and it can't go here or here. What if this is a 4? Is there a digit I have to use here? 2, 3, 3, 4, 4, 5. There's not a digit I have to use. This could be 4, and then this could be 2, 3, and then this could be a 5. As of right now, that's fine. 3 different digits, 4 different digits, 5 different digits, 5 different digits, 4 different digits. Let's look at this. These, what if they're the same? What if they're the same? Then this would be a 1. If these are the same, this is a 1. If these are not the same, this is equal to this times this. What can I do with that? I mean, this could be a 1, and then these could be the same. If these are the same, this is a 1. I could have 1, 1, 1, 1, and this could be different. If these are the same, this is a 1. If these are the same, this is a 1. But I think 1s are fine in either place still. Do I want to think about what digit I can't use in this column, or what digits I can't use here? I think just about anything is possible here, actually. Anything is possible. Wait, I know what these are. Hold on. 1, 4. This is a 2, 3, 5 for sure. Wait a minute. Okay. This is for sure a 2, 3, 5. So what's going on here? This plus this needs to equal this plus this. This cannot be a 1, but it could be a 2, 3, 4, 5, depending on what this is. Also depending on these. Certain options are not going to work here because this needs to be consecutive. So I can't do 4 and 3. I'd be left with 2 and 5 here, for example. So I need to be careful with that. Let's... Okay, think. The smallest this will be is 5. 2 plus 3. I don't have a way of getting 5 here because I can't use a 1. So this can't be 2 plus 3. Could it be 2 and 5? That would be 7. I don't have a way of getting 7. So I can't use a 2 at all here, actually. 2 plus 3 is 5, which I can't do because I can't use a 1. And 2 plus 5 is 7, which I can't do either. So this can't be a 2. This has to be 3, 5, which sums to 8. Meaning this is going to be a 2, so I need this to be a 4. Look at that. This is either a 3 or a 5, but I don't have anything to go with a 5 anymore. So this is going to be a 2, and this is going to be a 3, meaning this is a 5, and this is a 3. Oh, look! Nice. 1, 2, 3, 4, 5. How cool. Okay, so 1 plus 2 is 3, which is 1 times 3. 3 plus 5 is 8, which is 2 times 4, or 4 times 2, rather. 1, 2, 3, 4. 4 times 1. 1 is 1 times 1. Okay. What else do I know now? I can only have 2 different digits here. 1 and 4. This needs to be 3 different digits. I've already used 1 and 2. If this were to be 1, 1, like I was kind of talking about before, that would be fine. This would have to be a new digit that's not 1 or 4. Okay, this can only be 2 different digits, so these need to be 1 or 2 only. Okay, if these are the same, this is a 1. If these are different, there's no way this could be a 1. Okay, if this is a 1, this is also a 1. If this is 1, they're all 1s. Right? If this is a 1, the only way to get 1 is for it to all be 1s. If this is a 2, this could be a 1 or a 2, and this could be a 1 or a 2. They would need to be different. I don't think I can narrow this down more. But if this is a 1, they're all 1s. If this is a 2, then this is a 1, 2, a different 1, 2. Like if this is 1, this is 2. If this is 2, this is 1. Okay, let's look at this column. I need 3 different numbers. I've used 1 and 3. If this is a 4, this would also have to be 4 and 3 and 1. I have not looked at this yet. I need 4 different numbers here. I've already used 1 and 4. So this has to have 2 new numbers that are not 1 and 4. And then either... Okay, this has to be a 1 or a 4. But I need to have 4 different numbers for the whole column. So if this is already a 1 or 4, these are going to be 2 new numbers that are not 1 and 4. This is going to be stuck between a 2, 3, 5. Okay. That's good. That's good. I'm saying a lot. This is 4 different numbers. Can I figure this out? The lowest it could be is... These need to be different from each other, right? So the lowest this would be is a 2, 3. The lowest this would be is 6. I don't have a way of getting 6 with a 1 and something else, or a 4 and something else, though. 2.5. So I don't want this to be 1, 2, 3. What if this is 2, 3, and this is a 4? That would be 9. I don't have a way of getting 9 either. So I don't want this to be 2, 3. What if it's 2, 5? That would be 7. So this would either be 8 or 11. 8 would be doable if this is 4 and 2. So I don't want to take 2 out. 5 is still an option. Or 2, 5 is still an option. That'd be 7 plus 1 is 8. I don't want to do 11, but I could do 1, 2, and 5. So if this is a 1, this is a 2 and a 5, and then this is a 4 and a 2. Ooh. I need 4 different numbers here. If this is a 2, this would have to be the 5. And then it doesn't matter what this is. This would be a 2. Okay, this would break this row then if this was a 2. If this is a 2, doesn't matter if this is a 1 or a 2, but this would still only be a 1 or a 2. Maybe I should pencil this and see what's going on with this row. This is also either a 1 or a 2. If this is a 1, it's all 1. If this is a 2, this is a 1, 2 pair. I could have penciled that a long time ago. I need 3 different numbers here, and I've only used 1 and 2. So this cannot be a 2. This needs to be a 3 or a 5. Okay, that's a good way of looking at it. This needs 3 different numbers. I've used 1 and 3. I cannot use both 4 and 2. I cannot do 4, 2. That's too many different numbers. This has to be a 1, a 3, or this, or this. How do I want to mark that? A 1 or a 3 is safe, but then it can only be one new number, and it would have to be a repeat of one of these, or unless these are all 1s. How do I want to mark that? Maybe we'll just think about it. We'll keep it in our head. Okay, so my options are getting more limited here. I also know I need 4 different numbers here. If best case scenario, this goes 1, 2, 3, I would need a 4th number here. I know I need 4 different numbers here. I know that these are different. Let's look at this again if this can't be a 2. This could be 5, 2. If this is 5 and 2, that's the 4 and 2 situation we had before, which is too many numbers. So I don't actually want to do 5 and 2. And I already know that 1, 3, 2 didn't work because there's no way to get 6. So I can take out 2 completely. Meaning this column is going to have 1, 3, 4, and 5 as the numbers. This has to go 3, 5 because I need them to be different. So this is 8. This is either 9 or 12. 8 is not an option because I would have to do 4, 2, and that's too many numbers for column 3. So let's not do 3, 5, 1. Let's do 3, 5, 4, which would give me 12, which means I need to do 4 and 3, and hopefully that works with everything else. 1 number, 2 numbers. I need 3 numbers. So this is 1 and 2, and then either 3 or 5. That would be the 3rd number. This needs 4 different numbers. I've used 1, 3. I need 2 more numbers. So these need to be different. This will have to be a 2, and this will have to be 5. Different than these, I should say. So then this 5 makes this a 3. I can only use 3 different numbers here. I've already used 1, 4, and 3, so this has to be a 1. 2 times 1 is 2. Nice! Ooh, like this puzzle. Like this puzzle. These are so much fun. These are good. This one was definitely more thinking than the previous one. Oh boy. Oh boy. Let's look at number 3. Same rules as before. This is digits 1 through 6. Let's put some column markers on. Row and column markers. Yeah. I want to see those. That'll be really helpful. I should have done that before. Okay, let's start off by connecting. I think the game I had was called Pipes or something. I like all these different shapes that are very cool. The only way this one works is by going like this. So this one needs to go like this. This little one's gonna go like this. Sorry, I didn't mean little. This shape's important too. It's not small. Okay, so we have that part done. Where do I want to start? Ooh, okay, this is all the same number. This is the same number twice. Okay, so if this is all the same number, x plus x equals what times x? This has to be a 2. No matter what this is, it's going to be 2 times this. Okay. Neat, fun, cool. Meaning I can't use a 2 down here. What does that tell me? It also means that none of this can be a 2. Okay. What's this? This is all the same number, so this needs to be 3 times this. This cannot be the same as this, but this could be the same as this. Who's scratching my chair? What's going on? I normally have Loba's hammock next to my chair, but I was cleaning earlier and I moved it. It wasn't there anymore. I was looking at this. This is the same number over and over again, so this needs to be 3 times this. This can't be the same as this, but this could be, and this could be a 3. I don't know that, but it could be. What's another situation? If this is 2, 2, and 2, and then this is 1 and 6, that's fine. Well, this can't be a 2, because this can't be a 2. What options do I have to not be 3 times this? 2, 2, 2, 3, 3, 3 would be 3 times 3, which would be very bad. 4, 4, 4 would be 12. I could do 6 and 2. So I don't have to use a 3 here, because I could have 4, 4, and 4, and then have 6 and 2. That's an option. Okay, but we're getting there, kind of. What can I do with the fact that this is a 2? I can only use 2 different numbers here. This is going to be 3 different numbers. This is 4 different numbers. What about this is 6 different numbers? These shapes, this times this is this. A single cell. This times this is this. What are my options here? These could be the same digit, but that can't happen again. These could be the same digit, these could be the same digit, and that seems fine. So, I mean, like, I could use 1s. Could this be 1, 1, 1? Yeah, it could. One of these, they can't all be 1, 1, 1. But one of these could. I might have a lot of options for this also. Or I could have like 2 and 3 equals 6. 2 and 2 equals 4. Something like that. What about the fact that this is all the same number? Really, this is all the same number. Ooh, oh, wait. This has to be the same number as all of this. Okay, that might cause some issues. We might get stuck here. Okay. If this is a 1, 1, 2, 3, 4, this would have to be a 1 or a 2. So this would be a 1 and this would be a 5 or a 6. If it's 2, 2, 4, 6, 8, this also has to be a 2. The biggest this can get to is 12. 2 times 6. 2, 4, 6, 8. I have some leeway. What about 3? 3, 6, 9, 12, plus something else. This would have to be a 2 or a 3. This is either 2 or this. Okay, I don't think I considered that well enough. 2, 2, 4, 6, 8. This could be a 2 or something else. This could be a 2 or something else. It would have to be this digit if this isn't a 2. So 2, 4, 6, 8. This would be a 2 times... Like, if this is a 2 again, this could be a 5. Okay, that's fine. 3, 6, 3, 6, 9, 12, plus something would have to be 3 times something. I think I kind of want these to be the same. If these are the same, this is a 5. That's funny. Well, only if they're 2. If this is 3s, this can't be a 5 because that's 3, 5, and 2 in row 2. I think I can figure this out then. 3, 4, or 3, 4. 3, 6, 9, 12 plus anything is going to have to be 3 times 3 or 3 times 2, which this is automatically too big. I think these need to be 1s or 2s, but they can't be 2s because of this. So I think these need to be 1s. 1, 2, 3, 4 plus something would be 1 times this. This would have to be a 1 or a 2. Let's make this a 2. Okay. I think that has to go that way. I can't use 2s because this can't be a 2, and these have to all be the same. 3s make it too big. 3, 6, 9, 12. When this has to be either a 2 or a 3 is already too big. So yeah, these have to be 1s again. Meaning 1, 2, 3, 4 plus something is going to be 1 plus this. If this is another 1, it has to be 1 or 2 for 1. 1, 2, 3, 4, 5 would make this 1 times 5, which is too many digits here. This is a problem. Something's wrong. I thought I had it, but that doesn't make sense. 1 plus 2, 1, 2, 3, 4. Are the rules different for this one? I assumed. Each row n and each column n must contain exactly n different digits with repetition allowed as necessary. How does this work? This has to all be the same. And like I'm positive this has to be a 2. Because these are all the same. Is 2 actually fine here? Did I think about it backwards? If I make these 1s, this has to be a 1 or a 2. So this can only be 1 or 2. I think I thought about it backwards. I think this needs to be 2s. It can't be 2s because of this. How does this work? I need 6 different numbers here, so this has to be different than 2, meaning all of this cannot be a 2. 1, 2, 3, 4 plus something. I can't do 2s. What if they can't all be 1s because this is addition? 1, 2, 3, 4, 5. Can I use zeros? Oh, I don't understand how this works. 1. Let's pencil in 3s. 3, 6, 3 in the corner. 3, 6, 9, 12 would be 3, but then this is stuck being a 2 or a 3. What if I go even bigger? 1, 2, 3, 4, 5. What if these are 5s? 5 plus 5 plus 5 plus 5 plus 5 equals 5 times 5. Oh, it was right there. I just assumed big numbers would not work because big numbers would not work. Fives make sense. The same thing. Okay, square numbers. Yep, square numbers are really good for this. Should have been thinking about that. 5 plus 5 is 10, which is 5 times 2. Nice. Okay, we got there. We figured it out. So this needs to end up being 3 times 5. That's the only way that works. This can't be another 5 because this needs to be 6 different numbers. So this needs to be a 3 and this needs to be a 5, meaning the digits for this column are 3s and 5s. This can't be a 3. It'll have to be a 5 because this can only be 5s and 2s. Okay, we're getting somewhere. Let's look at... No. This maybe? This can't be a 3 or 5. This is going to be a 1, 2, 4, 6. I don't know if I want to think about that, actually. This still has a lot of options. This, maybe. I know what this is going to be. I know exactly what this will sum to, actually. 1, 3, 4, 6, or I will in a moment. 4 plus 6 is 10, plus 3 is 13, 14. This is 14. 14 plus this is going to be this times this. What can I do there? 14 plus 1 would be 5 times 3. That's an option. Nope, I can't do 5 or 3 here. This can't be a 3. This can't be a 5 or a 3, so this is going to be a 1, 2, 4, 6. So this is 14. I don't want a 1 here because I can't do 15. 1, 2, 3, 4, 5, 6. I don't want a 1. Let's think about 2. This would be 16. Can I get 16 with 2 numbers? Nope. If this is a 3, that's 17. That's worse. What about a 4? That'd be 18. I could do 6 and 3. I cannot do 6 and 3. This is gonna have to be 5 and 5, isn't it? 6, I mean. 14 plus 5 is 19, which is not doable. 16, this would be 20. I could do 5 and 4. I think it's gonna have to go that way. That's gonna be the only option there. Meaning this can't be a 4, it's a 1 or a 6. This is going to be 1, 2, 6. Wow. Wow. Okay. This is 14 plus 6 is 20, which is 5 times 4. Okay, cool. What else can I do? I need to use a 2 here. One of these is going to be a 2. And 2 times this is going to equal this. So or 2 times this is going to equal this. So these need to be different numbers. Wherever the 2 is, they need to be different numbers up here. I could also think about the other way, that one of these needs to be a double number. I need to use some number twice. Okay. We'll come back to this, I think. Well, I have options here. 1 times 3 would make this a 3. I can only use 3 different numbers, so this would be 1 and 3. 1 times 5 would make this a 5. That's 2 mini triple numbers, so I don't want to do 1 and 5. What about 2 and 3? That would be 6. That's probably fine. 2 and 5 would be 10. I don't want to do 2 and 5. I don't think there's any way I want to use a 5 here. 6 and 5 is way too big. 1 and 5 is too many 5s, so let's make this a 3. I almost went ahead and marked this as a 5. That's not how it works. If this is 1 times 3, this is a 3. If this is 2 times 3, this is a 6. If this is 6 times 3, that's too big. So this is either 1 and 3 or 2 and 6. Either way, that's all 3 numbers for this column. So these need to be not a 4. 1, 3, 5 or 2, 5, 6. We'll come back to that. I'm not sure how to pencil that right now. Okay, we'll look at this. I've already used 3 numbers. I need to use 2 more. So this is stuck being a 1, 2, 3. I can't use 4, 5, or 6 again. which makes this interesting. Can I take out numbers out of here? I don't think so. Either this is a 3 and this is our duplicate, so this is not a 3, or this is a 6, and I still need a duplicate somewhere. I'll come back to that. What's happening here? Could this be 1 and 1 and 1? This would need to be a 6, meaning this would have to be a 2, which is good for this. This would be a 6. I think this could be 1, 1, 1. Is there any way this could be a 6? 1 times 6 would make this also a 6. That'd make this a 2 and this a 6, so this would be my duplicate. This would be a 1, this would have to be a 4. I think that's fine. I was trying to take 6 out of here, really, but 6 and 1 works. I don't want to do 6 and 2, I don't want to do 6 and 3. But 6 and 1 works. 1, 1, 1 works. We'll come back to this. I'm not sure I can narrow it down to just one option right now. I can only use 3 different numbers here. A 5 and a 6 I've already used, so these need to be 5, 6, or a third number. Maybe I want to look at this. This is also only 3 different numbers, which are going to be 5s, and then whatever happens here. Do I want to look at this? 4 different numbers. I've already used 5. This can only be 3 different numbers. So I can't do 1, 1, 1. But this could be the same, and this could be 1 times this is this. If these are the same, that would be an option. Maybe I do want to look at my options here. If this is a 1, it's because these are the same. If this is a 2, it's because this is double this. If this is a 3, it's because this is 3 times this. That's options. Where else am I limited? I haven't really looked at this. You know, for here, I can only have 3 different digits. So if I put a 3 here, these also have to be 3, 5, 6. Let's maybe look at this. This plus this. If this is a 3, this will be 3, 5, 6. Let's shade this red because this is wrong. I'm just looking at if this is possible. 3, 5, 6. So if this is 3 plus 3, that'd be 6. There's no way to get that with. Oh, this is helpful that I know this is a 5 actually. These need to sum to a multiple of 5. Let's just look at that instead, actually. So a multiple of 5, I have 5, 10, 15. If this is a 3, this has to be a 2, and this has to be a 1. That is 4 different numbers, so this can't be a 3. Because I can't use 7s to get to 10, so this has to be another 5. 5 times something equals 5 plus something. A 0, another 5 are going to be my only options. Anything I add to this that's not a 5 won't be a multiple of 5. So let's make another 5 here. 5 plus 5 is 10, which is 5 times 2. So my 3 numbers for here are 2, 5, and 6. Meaning this can't be a 1, it can't be a 3, it can't be a 4, it has to be a 6. So these are not 6. This is going to be a 1. Meaning I can't use a 1 in here. This is going to be a 2, which became 6 here. So this is a 6. 1 also means 1 won't happen here. This is 2 different numbers. This is 3 different numbers. This needs to be 4 different numbers. This needs to be 5 different numbers. I've used 3 different ones so far. This is 6 different numbers. 3 different numbers here. This has to be a 2, 6, or 5. This needs to be 4 different numbers. I've already duplicated a 5. 5, 2, 6, or a new number. I have not duplicated a number yet here. If this is 1 times 6, this will be a 6. If this is 2 times 6, this is bad. This is my double number, 1, 3, 5. This can't be a 3. This will have to be a 4 in order to get 5 different numbers. So this is a 3. This needs 5 different numbers, and I've already duplicated a 5. So let's not make this a 1. It's either a 2 or a 3. This needs 4 different numbers. This will have to be something different. 1, 2, 3, 4, 5, 6. Okay, let's see what happens here. I don't think there's any way I want this to be a 1. There's no way this can be a 3 either, so this is gonna have to be a 4, and hopefully 2 and 2 work here. 2 times 2 would be 4. 2, that's 4 different numbers. This is 3 different numbers. 5, 2, 4, 6, 4 different numbers. 5, 6, 2. I think that works. Ooh, that one made me use my brain. Ooh, I was thinking on that one. Oh my gosh, these are so much fun. Like this puzzle. My coffee's empty. Thinking about these as in like, I'm limited to only using these digits here. And also being, I need to use 6 different digits or 5 different digits or 4 different digits. It's interesting having to think about both limitations at the same time. These are a lot of fun. We have one more. This is product link Somedoku 4. Let's do show row column. I didn't even look at these, but it would have made it easier. Double check that the rules are the same. Fill each cell with the digit from 1 to 6. Each row n and each column n must contain exactly n different digits. Everything is the same. All right, let's start with the fun drawing part. I need to use... Okay, so I should explain the way I think about this probably. I've done a lot of these and I didn't really explain it. I need to use this spot somehow, right? The only way I can get here is if I connect red to red. Same thing here. The only way I can use this spot is if I connect the plus sign to the plus sign. So I kind of use that same logic over and over and over again. I could take this orange up this way and go somewhere, but then I have no way of getting this light blue to this light blue. So let's go this way with that. Next, the next spot I'm kind of limited in is going to be these spots. So let's connect the triangles here. The only way the squares can connect to each other, I can't go through other spots, so let's connect them here. I have this nice shape here where I can connect yellow. And then I just need to connect orange. That made an interesting shape. I need to connect the orange diamonds to each other and then the pink hearts to each other. Very cool. How do I want to look at numbers here? I've learned now that this shape is interesting. That if these are all the same number, this is x plus x, so this needs to be 2 times x. So this will be a 2. This is crazy. These are all the same number. So these could either be 1s. 1, 1. No, they can't be. They literally can't be. They literally can't be because this is 1 plus 2. 1 plus 1 is 2, 3, 4. They literally can't be. That's the opposite of how that works. This needs to be, if these are all the same, 1, 2, 3, 4. They need to be 4s because 4 times 4 is going to be 4 times 4. So these are all 4s. Okay. That's the only way that works. I thought about it backwards again. Which makes this interesting. This needs to be a 1, not a 0. Because the sum of this line is 4, so 4 times 1 is 4. Okay. Meaning the 2 numbers for this column are going to be 1 and 4. But then the 2 numbers for this row are going to be 4 and 2, so this has to be a 4. These are either 2s or 4s. This is fun. This is anywhere from 3 to 12. Not anywhere, but my options would be somewhere between 3 and 12. This is a 4, this is a 2. I need to put, I don't need to put a 4. I need to put a 1 somewhere here, and it can't go here, so this is a 1 somewhere here. We'll come back to that. This is interesting. What if this is 2, 4, 6? I don't want this to be all 2s because I can't do 4 and 2.5. What other combinations are there? What if on the other end, if this is 4, 4, and 4, this could be a 3. What if this is my options for multiples of 4? Let's think about it that way. 4, 8, and 12. I could do 16 if this is a 4, but I don't have enough 4s. So this needs to either sum to 4, 8, or 12. Can I get 4? No. I could get 8, 2, 2, and 4, or 4, 2, 2, something like that. So this could be a 2, or this would be 4, 4, 4, and this would be 3 and 4. Okay. Next. Maybe I do want to look at this. I can only use 3 different numbers here. This can't be a 4. It could be a 2 if this is a 2. This is interesting again. This is interesting where these have to be different digits and these have to be different digits. Whatever this is, these could be the same digit. This could, oh, I was going to say 2, 2, and 4, but that doesn't work. Okay, this needs to be something different than 1, 4, and 2. So this is not a 1. It could be a 3, a 5, or a 6. Without using a 3, how do I get 3? I can't. I would have to do 1 and 3, and I can't use another 3. Without using 5, how do I get 5? I can't. So this has to be a 6. And these are going to be 2 numbers that multiply to 6. Without using 6. So I can't do 1, 6. I could do 2, 3 if this is a 2 and this is a 3. And that's going to be the only way to do it. I'm not used to multiplication so much in Sudoku. I'm used to addition. It's like, yeah, there's lots of ways to get 3, but I need to do multiplication. Can't do 1 and 6 because I can't repeat those. It's going to have to be 2 and 3. Whoa. Which means I know what these 2 digits are. This is a 3 and a 5. This is going to be a 1 and a 5. Yes. Okay, this can only be 3 different digits. This can only be 3 different digits. We're stretching ourselves thin here. This is interesting. These could be the same number. They could both be 5s. 1, 2, 3, 4, 5. Well, if that were the case, these would have to all be 5s. So maybe I sneak a couple 6s in there, actually. We'll come back to this. Maybe. Shoot. What else do I want to look at? This is 5 different numbers. So if this is a 2, oh, this can't be a 2, because if this is a 2, that's my repeat, and this can't be a 2 or a 4. So this needs to be a 3, meaning this is going to be 4, 4, 4. Whoa, nice. 4 is my repeat. This is a 3 and a 2, meaning these need to be between 1, 5, and 6. They need to be different from each other. They need to be 1, 5, and 6. Chosen from the numbers 1, 5, 6. Okay, nice. 2 different numbers, 1 and 4. 3 different numbers. I've used 4 and 3. So if this is a 1, this has to also be a 1. That's an interesting little situation there. If this is a 4, this could be whatever it wants. This is stuck between 3, 4, 1, or 5. I need 4 different numbers here. I've already used 1. This has to be 3 different numbers. This could be the same, and then these could be different. This shape, I feel like should be pretty limited. But with only needing to use 4 different numbers here, I could have repeats. 3 different numbers here. What am I doing here again? What if this is 1, 1, 1? This could be 3 times 1. Or 1 times 3. What if this is 4, 4, 4? 3 and 4. I need to use 3 different numbers here. 4 is fine, so 3 and 4. This would have to be a new number. Maybe I do want to look at this. No, I feel like this is it. Okay, this could be 1, 1, 1, meaning this would have to be 1 and 3. This could be 1, 1, 4, which would give me 6 here, which would be 2 and 3, or 6 and 1. I can't do 6 and 1 because this is broken then. How do I want to think about this? Okay, wait, the digits for this, I know what they are. It's 3 and 4, and then either 1 or 5. I did know that. 4 and 3 are 2 of the digits, but this can't be 4 or 3, so this has to be 1 or a 5. So this is stuck between 1, 3, 4, 5. I do want to look at that more. 2 of the digits here are 4, and then either 3, 5. If this is 1, 1, 1, this could be 1 and 3. This could be 3 and 1. If this is 4, 4, 4, I can't do 2, 6, but I could do 4 and 3. Could I do 4 and 3? 4, 3. This would need to be either 4 or 3, and this would need to be a new digit. Is there any way I can use a 5 here? Is there any way this sums to 10? Or 5? No. No. Nope. This could be a 1 if this could be a 1 if this is a 3. Because this would be 1, 1, 1. Or I could have like 1, 1, 4, which gets me to 6. What if this is a 3? This could be a 1. If this is 1, 1, 1. Or this could be a 3 and 4, 8, 9. Oh boy, I could do 3, 3 and have 4, 4, 1. Or this could be 3, 4. Well, this can't go 3, 4 because that would mean this is 4, 4, 4, and that's 3 4s in row 5. Shoot, I feel like I still have so many options there. I can only use 3 different digits. Let's think about it that way. If I make one of these a 5 now, that means I can't use 1s here. Is that okay? Is not using a 1 okay? 4, 4, 4, 4, and 3. Yeah, it's fine. Let's think about this. Actually, I'm very limited on my options here. Is there any way this could be 1, 3? Is there any way this could be a 1? I actually think that's an excellent thing to think about. I don't think there's any way this could be a 1. Could these all be 1s? 1, 2, 3, 4, 5. This would have to be 1, 5, and these would all be 1s, but this is broken then. It would go 1, 5, 5, 6, 7, 8, 9 at the smallest, and 1, yeah. Well, that makes things a bit easier. That does make things a bit easier. 4, 3, 5 is what I'm limited to here now. These can't be 1s. This is going to have to be a 4. These are still fine to be 1, 4, but this is definitely a 4. These are limited to 4, 3, 5. What does that tell me here? 15? Seems fine. 25. With a 1? If this is a 5 and this is a 5, this is a 3. So this is 4. So this would have to sum to 21, which is not possible. So let's make this a 3 and this a 5. Yay! Making progress. Okay. That was an excellent catch. Very helpful. This needs to be 5 different numbers. I've already used a 4. I know that this is a 3 and a 2, so these need to be different from each other. This needs to be 5 different numbers. This is 6 different numbers. 413! Look at that. That's the best day of the year. 2 different numbers. I've used 4 and 1, so this is limited to a 4 and a 1. 3 different numbers. 4, 3. This is either a 3 or a 4 or the same number as this. Okay. Let's look at this again. If this is a 4, this can either be 4, 1, 1, which would be 6, which I cannot get right now, so I don't want that to happen. What about 4, 4, 1? That would be 9, which would make this 3 and 3, and this would have to be a new number. That's the only way to do that. If this could be 4, 4, 4, which would make this 4 and 3. Is this a 3 no matter what? Is that what just happened? I don't want to forget those. Let's do it this way. 4, 1, 1 is 6, which makes no sense. I can't do that with a 3 or 4. This would have to be a 2, and I already said this can't be a 2. For reasons I don't remember. Why did I have this as... I had this as 1, 3, 6 because of my options for this, didn't I? Uh-oh, I think I could have a 2 here. 4, 1, 1 sums to 6, and I could have 3 and 2. Ooh. I think I was putting options in there of how this works, and I think I omitted that on accident. I think I need to have a 2 there. Shoot, okay. 4, 1, 1. I don't think I based anything off of that. I hope not. 4, 1, 1 could be 6. That could be 3 and 2. What about 4, 1, 4? 4, 4, 1. That is 9, so I could have 3 and 3. That's the only way to do that, to get 9. Or what if I have 4, 4, 4? That would be 12. I can't put another 4 here to get 3 and 4, so this would have to be 4 and 3. I need 3 different numbers in here. If this ends up being a 3, this will have to be a new number. Okay, I think I still have options here. This is 3 different numbers. It is 3, 4, or 5. I might want to look at this. This is either a 3 or 4 or a new number. Ooh, I need to use 4 different numbers here. Wait, I can do better math here. Hold on. Hold on. This is 15. This is 10. This is 9. This is 15. This is 10. This is 9. If I use a 6 here, these need to sum to 3. Can I do a 1 and a 2? Oh, I think it's possible. These 3 need to sum to 9. That's not a what if, that just needs to happen. They need to sum to 9. So if this is 1 and 5, this will be a 3. If this is 1 and 6, this will be a 2. If this is 5 and 6, it's broken. I need to use a 1 here. This is either a 2 or a 3. Meaning I can only have 1 duplicate here. It's going to be something here. These can't all be 3. So one of these is definitely a 2. Meaning one of these is a duplicate of either the other one. Either it's 2, 2, or it's 2, 3, and it's a duplicate of this. Meaning I can't use another duplicate, so this can't be a 4. It'll have to be a 1. Meaning I'm not actually going to have a 12 here. I'm now either at 6 or 8, which would be 3 times 2. Not 8, 9. 3 times 2 or 3 times 3. This has to be a 3. Okay. 3 times 2 or 3 times 3. It's depending on this. What can I do with the fact that if this is a 1, this is a 2, and if this is a 4, this is a 3? Can I do something with that? I'm not sure. One of these is definitely a 1. One of these is definitely a 2. I could have another 4, 1, 3. This now can't be a 1 anymore because my duplicate is here. So I already have a 1, so this is not a 1. This is a 5 or 6, meaning this is a 1. So this needs to be 9. If it's 1, 5, this is a 3. If it's 1, 6, this is a 2. Okay. This needs to have 4 different numbers. I have 1 and 4. This is also a 1 or a 4. So this needs to be new numbers. I like how I'm like starting on the outside and then like working my way into the middle. That's cool. I need to have 4 different numbers. I only have 2. So these need to be 2 different digits that aren't 1 and 4. 2, 3, 5, 6. And they need to be different from each other. This can only be 3 different numbers. I think this is okay because this could be a 3. This is 4 different numbers. These need to include 2 different numbers. Okay, let's look at options here. Whoa. Is there any way this could be a 2? No. Is there any way this could be a 3? No. Anyway, this could be a 5? No. This is going to have to be a 6, meaning this is going to have to be 2 and 3. That seemed weird. This has to be a 6, meaning I need to take out 4 and 5 out of here, and this needs to take out 5 and 6. It'll have to be a 2 this way and a 3 here. Okay. 4, 4, 3, 2, 3. That's 3 different numbers. This is still fine to be 2 or 3. I need 4 different numbers. This is fine to be 1 or 4. I need 4 different numbers here. 1, 2, 3, 4. So this can't be a 2. It'll have to be a 3. What does that mean for this? This was 15. This needed to be 9, right? This, let's do it this way. 10, 9. Yep. 8, 5. I already have a duplicate number now, so this has to be a 2. Math makes this a 1. Very nice. Very nice. Oh my gosh, these are so much fun. Wow. And I like the 2 parts to the puzzle of you have to start by figuring out where the lines are and then put numbers on them. I appreciate the 413. That's very cool. Whoa. And I feel like I don't feel like I got super stuck either. Like, I'm happy with how I was able to progress with it. And I was always able to find something to do, which was really good and feels really nice when that happens with me since I'm learning these. Very cool. And of course the math I always appreciate. Whoa. The geometry was so nice. And like, I started by the 4th puzzle, like recognizing shapes. Oh my gosh, super cool. Very nice puzzles, Elytron. Let me know how you all did on in the comments. These are really nice. My recording is 1 hour and 6 minutes right now. Very cool. Very nice.